Hey everyone, welcome back to Jabaz Electronics. I'm your host Jabaz, and today we're diving deep into something that lies at the core of every electronic system: rectifiers, filtering, and power regulation. Whether you're building a simple amplifier, a radio, or a high-end power supply, understanding this process is absolutely essential. So grab your notebook and let's light up the world of DC power. Most of our electricity, the one that comes from the mains, is alternating current, or AC. It continuously changes direction, oscillating 50 or 60 times per second depending on your region. But electronic circuits like amplifiers and microcontrollers prefer direct current. The kurkran durstans kurpaingsi kurtin chiu kurkurturn stew. A steady flow of electrons in one direction. So our first job is to convert AC to DC, and that's where rectifiers come in. In the simplest form, a half-wave rectifier, we use just one diode. During the positive half cycle, the diode conducts and allows current to pass. During the negative half, it blocks current, leaving the output zero. The output is pulsating DC, one half of the wave. Simple, but inefficient, since we're wasting half the input power. Next is the full-wave rectifier. Here, we use a center-tap transformer and two diodes. Each diode conducts on alternate half cycles, but the output polarity remains the same. Now we've doubled the frequency of the pulses, giving smoother DC. And the most common, the bridge rectifier, uses four diodes arranged cleverly so that both halves of the AC waveform are used without needing a center-tap transformer. This configuration is efficient, compact, and found in most modern power supplies. The output, though still pulsating, is ready for the next stage: filtering. After rectification, our DC still looks like a series of ripples. To make it smooth, we use filters, typically capacitors, inductors, or a combination of both. When a capacitor is connected across the output, it charges during the diode conduction and discharges when the voltage drops. This fills the gaps between the pulses, reducing the ripple. The larger the capacitor, the smaller the ripple, but too large, and you risk high inrush currents. Balance is key. An inductor resists changes in current. Placed in series, it smooths out fluctuations. Combine it with a capacitor, that's an LC filter, and you get even better smoothing. It's common in high-power linear supplies. In low-current circuits, RC filters, resistor plus capacitor, are often used to remove small ripples, especially in pre-amplifier power lines or analog stages. Even after filtering, voltage can still vary with load changes or AC fluctuations. To ensure a stable, constant voltage, we use regulators. A simple form of regulation uses a Zener diode in reverse bias. When the input exceeds its breakdown voltage, it maintains a constant output, useful for small circuits or voltage references. To handle more current, we use a series pass transistor controlled by a reference voltage, often from a Zener. This forms a linear regulator, capable of supplying larger loads with minimal ripple. Then we have integrated circuit regulators like the 78XX series for positive voltages and 79XX for negative. For example, 7802 outputs 12 volts, 7805 gives 5 volts. They provide excellent regulation and built-in protection. For higher efficiency, modern systems use switch-mode power supplies, SMPS. Instead of burning off excess voltage as heat, they rapidly switch the input using transistors and store energy in inductors or transformers. These converters can step up, step down, or even invert voltages with efficiencies over 90%. That's why they're used in computers, chargers, and amplifiers. So, the complete power supply chain looks like this. 1. Transformer, steps AC voltage up or down. 2. Rectifier, converts AC to DC. 3. Filter, smooths the DC output. 4. Regulator, stabilizes the voltage for the load. Every stage plays a vital role. Without proper rectification, your DC is noisy. Without filtering, it's unstable. And without regulation, your circuit could fail. And there you have it. the full journey from alternating to regulated direct current. Understanding rectifiers, filters, and regulators is the foundation of reliable electronic design. If you enjoyed this breakdown, don't forget to like, subscribe, and stay tuned, because next time we'll explore power supply protection circuits and how to design your own linear and SMPS units from scratch.